So for those that don't know, this is Dr. Kevin Johnson. He holds one of the Penn Integrates Knowledge professorships at the University of Pennsylvania. If you're not familiar with what this is, basically it means that the holder of this professorship has to be appointed in at least two or more schools at Penn. And there, I don't know how they require this, but you're required to draw on the breadth of your knowledge to collaborate with colleagues on boundary breaking research. More specifically, he's the David L. Cohen University Professor of Pediatrics. He's a board certified pediatrician, biomedical informatics, and science communication. Prior to that, he was the chair of the Department of Biomedical Informatics at Vanderbilt University and the senior vice president for health information at Vanderbilt University Medical Center. He's an internationally known developer and evaluator of clinical information technology. His interests are wide and varied, focusing on the development and adoption of clinical information systems to improve patient safety and compliance with practice guidelines. Um, he's also widely known for his work on e-prescribing and computer-based documentation, as well as his creative endeavors. If you have not seen it, was the producer and director. Were you the director? Just the producer
I was the producer.
of a feature-length documentary about health information exchange. And most recently, he's one of the architects of the National Academy of Medicine's Healthcare Artificial Intelligence Code of Conduct. He has more honors than you can spend time putting down into words. I'll just note that he's an elected member of the National Academy of Medicine, the American College of Medical Informatics, and the Academic Pediatric Society. And with that, I will turn it over to Kevin.
Thank you very much, Brad. It takes one to know one, since you have more than anybody would care to remember plus one. So, um, anyways, thanks for giving me a chance to talk about the project. I know that the format that we typically use is about 20 minutes of me talking a little bit, and then the rest of the time questions. And I really hope that there's lots and lots of questions. I'm going to just scratch the surface of a fair amount of work that's going on in my lab. Um, and I hope I have an up-to-date picture of the people in my lab at the end. I didn't check it to make sure everybody's in it because it's becoming a pretty big lab. The project I'm going to talk about is called the Observer Project. And the little byline here, transforming healthcare from the outside, has been one of the missions that I've actually had since I gave a TED Talk years ago about, and Brad should remember this because he helped to motivate my thinking about it, called Can a Second Grader Fix Healthcare? I was in one of our faculty meetings, and I asked the question, when did all of you think that you were going to be doing what you're doing? And Brad said he knew he was going to be a computer scientist in second grade. And I found out from many of the people that second grade and third grade were kind of that moment. And it was sort of culminated in a science fair project a few years later. So my TED Talk talked about that. But you'll see that there's some challenges with the work that I want to see done in our field. And this project is designed to do that. Very appropriate for, sort of the ELSI side of also what your project is about. So I'm a primary care doctor. I'm a pediatrician, but I also happen to be a patient who sees primary care and have had quite a few primary care misadventures over my life. What's very, very interesting is what the Kaiser Family Foundation wrote in this piece, which is known as the front door. Primary care is changing. Under pressure from increased demand, consolidation, and changing patient expectations, the model of care no longer means visiting the same doctor for decades. KFF Health News looks at what this means. Well, what it really means is that it's a field in crisis, that 80% of internal medicine residents, including two-thirds who actually said they were going to do primary care, don't plan to pursue it once they get out of residency. Office visits to primary care clinicians are continually going up, both thanks to a larger insured population, but also thanks to a model that is no longer able to solve all of the major challenges patients have in a single visit. There's a need for an additional group of primary care clinicians. As you can see, it's quite a large number. And it's important to note that primary care clinicians are not the top paying group, which means it is no way very marketable. And the average primary care clinician is working 18 hours a day. Many of the doctors here at Penn, what I've talked with, won't even take vacation because their message basket volume is so high that they don't want to offload that to anybody else who's also burned out. And about 48% of physicians report that. At the same exact time, there's enormous numbers of technologies that you can find written about to make healthcare smarter, i.e., to improve cognitive support in healthcare. And you can see the slide here, but the features that we know we can find using the data and the methods that are produced by groups like you guys and me are summarization, both spoken and unspoken, assessing patients and others' cognitive abilities, detecting biases, whether conscious or unconscious, quantifying activities. The simple example is how often did the patient stutter? How long were the silences between words? And how often did that occur? Uh, and being able to quantify other activities that might be happening, like, for example, how long did the patient take to walk, or was the patient engaging in particular strategies to communicate, and can we detect those? Using a lot of what we see here with machine learning, perception, and language, there probably are way more features to detect. And part of the challenge is, how do I get this knowledge from engineering into medicine? And so how do we get there from here? Well, one of the ways to do that is to think about a data resource that could be available not just on the Penn campus, not just in our medical center, which is shown on the upper right, maybe not just even the world, the country, but also the world. Taking the data from these settings and coming up with a way to share it has been a big part of my mission since I've been here at the University of Pennsylvania, with a goal of kind of creating a view into the exam room, the computer, and the mind of a clinician for outside groups to use as data for research. So we have created a first of its kind repository called the Observer Repository. The letters in Observer actually do, it's an acronym, but we don't use it anymore because it's pretty self-explanatory. Essentially, imagine that we take the visit that's in the center, we get video of it, we get audio from that visit, we have all of the EHR artifacts, we have patient and clinician satisfaction information to tell us how well the visit went. And we have the ability to integrate any sensor information that we would like to include, for example, gait assessment sensors. So taking all of those data, we've created a repository. There's a paper that's coming out about the data set itself in JAMIA, and there's a paper that's now in the works to get this repository, probably in one of the nature journals, to talk a little bit about this, because again, the goal is really to get a larger group than just informatics to know about it. So it's a complex schematic. For those of you who've built any sort of repositories, you'll appreciate some of this, but for the purposes of a 20-minute talk, the key thing is that we have a number of data types that are coming out of that spigot in green. We de-identify and keep identified video depending on the patient, audio, we have the transcripts, we have electronic health record data, we have electronic health record autologs, and then we have commentaries for some of the visits where we've actually asked patients and doctors to tell us how the visit went, but more now we have surveys. We take those data, we take them through a pipeline that ensures that they've been fully de-identified. And along the way, we have discovered that there may be metadata or there may be derived methods that we can actually use to add to the data set that would be typically available on these for each of these patients. And those are what we call the derived methods and the derived types. And what I'm going to focus on is really just based on the work that we've started with this particular data set, not larger projects that are now in the pilot phase that are being done by other investigators around the country, because we've already started giving out some pilot funding. One of the first things we had to do is to de-identify, to the extent possible, the video that we have in our data set. So video consists of an audio that can be identifiable, words that can obviously contain identifiable information, and pictures. And so we created a system called MedVid-DID. The paper is linked below. You can pretty much search for MedVid-DID and you'll find the paper. It's in JBI, Journal of Biomedical Informatics. It's also on medRxiv, which essentially takes the data and uses a 6-stage process that I will not go through here to eliminate all of the PHI, to obfuscate any part of the video that we think could be identifying. And we do that in 2 different modes. What you'll see in the lower left under method is a comparison of the modes. Manual basically means we do some things and we look at the entire video. That gets us a roughly, close to 100% success rate with two people looking at it. But we have a mode called precision privacy preservation, where we attempt to identify, to opt to blur out through Gaussian blur any identifiable parts of the video. And as you can see, that gets about a 50% success rate of completely de-identifying videos. So if we take 150 of them, generally speaking, are de-identified, and there are parts of the other ones that still require work. We have another method, which you see on the right, called greedy privacy preservation, which is essentially that we do a Gaussian blur on the entire video, and then we replace the people to the extent that you can see on the right with key points and skeletons as a way to basically say you can see where the people are, you can see how they're interacting, but you actually can't see much about the people other than their gender, if depending on their gender mapping to actual reality, and their race and ethnicity if you look at color that way. So I won't get into all of this, but we have this method. Um, we've been using it for quite some time here. We are going to have a third-party assessment of the entire data set because one of the challenges with a data set like this is that all of the components may be de-identified, but it may still be possible to re-identify. So there's someone on the call who knows we're going to be pulling him in to help us with that. Um, this is just an example of what the video looks like. People have often said, well, how much information is lost? And that's one of the experiments we're now working on. But this is an example of the video.
Okay. Blood work stuff looked pretty good. The only thing that you had was your A1C, which is the diabetes test, the tiniest bit high, not the diabetes level.
So you can tell that there's three people. There's two people who are in patient roles. There's a person who's in front of a computer who seems to be talking quite a bit. And frankly, if you notice the pronouns, we can establish a role. That's actually a paper that one of my students, Andrew Zielinski, put in. It's going to be presented at PSB this year. So we can do role identification fairly easily using both the words and the positioning on the screen. Um, and we now have 226. This is actually a little bit old. You can see the update here. So we're higher than this. We're collecting about 4 new patients a week. So we have close to 250 or so encounters right now. Most of them are de-identified completely at this point. We keep everything for our purposes right now. Everything is in an access controlled tier, and we have multiple departments that are represented. The point being, we have a fairly large data set. For each of these, we have room views, surveys. We have an egocentric camera that the patient wears, an egocentric camera that the clinician wears. We have the transcript, we have the annotations, et cetera. We've also gone into our neurology department because a couple of our earliest projects had to do with quantifying signs and symptoms that were related to aging and mild cognitive impairment. So we wanted to explore what those visits look like. One of the other things that we did fairly early on was include a qualitative component in this study. And I'm going to zip through because it's been 19 minutes. I probably have 5 minutes left. But we did a qualitative set of studies. And the way we did that was we created a book of nationally representative people that represented lots of different stakeholder groups. And we called that group the Book Club, not because they're reading a book, but if any of you have been a part of a book club, you know that the goal is to have some shared experience and to use that shared experience to inform conversations. In this case, the conversation is, what do we see and how could we imagine improving it using AI or other technologies? This was all a project that's called Reduce that I did, which is related to Brad's work on statements, which is essentially reimagining documentation using computational enhancement. So the book club, first thing noticed was every single room was different. Patients are seen in various configurations of rooms. If you think about what you just saw, you can imagine which room this might have been, for example, but there's a set of configurations that are all different. And therefore, the interaction that occurs from provider to patient is also and with the computer is also different. The book club has a paper that's coming out that talked about sort of a qualitative assessment. And some of the key themes from our book club was that AI was viewed when people thought about it as going to be an adjunct, not a replacement, that we could see reasons why AI could support decision-making and workflow, but we wanted to make sure we at least initially preserved autonomy, and we saw that. We saw the EHR as a barrier as well as an opportunity. We saw that there were serious issues, no surprise to any of us who've seen a primary care doctor, serious issues between the patient and clinician relationship. And we saw lots of examples of disruption and thought about lots of ways we could improve that. We also saw some ways we could enhance it based on how we design the room and or the technology. The main concerns are what I think are leading us to be using AI already in areas like ambient scribing, which I'll get to in a slide, which was depersonalization bias and then erosion of the relationship. So the book club is continuing to look at these and to brainstorm about what care could look like differently based on what we see. We think this is really going to be useful for these other groups to see what are we as clinicians and other stakeholders observing, and then they can use this data set to do other analyses as well as to potentially fine-tune models. One of the early projects that I was doing, many of you may know that healthcare has its first ever sort of plateau of productivity, if you know the Gartner Hype cycle AI intervention, which is ambient scribing, which is when you put your phone or some other device in between the patient and the clinician. That device records the entire visit and summarizes it into a provider note. So this is a study that I have in JAMA from last year. And the key thing I want to point out here, you can read the study, is in general, everything that we looked at in terms of effects of using ambient scribing favored ambient scribing over the manual process. But note that one of the other issues was the length of the visit notes has increased. Okay, so it's about a 15% increase in notes. And the question then is, so what's going on there? Could it be that there's more concepts? Was the visit a better visit and we learned more? Could it actually be that there was so much other conversation that there actually is now noise in the note? And will it be a bad problem in that will the note take longer to read, which actually could affect the cognitive burden downstream, sort of a cost shifting problem? So one of the nice things about the Observer Project is we are uniquely set up to answer that question because we have visits with and without ambient scribing, and we can extract all the concepts from the actual transcript, which gives us what's called recorded performance, as well as all of the concepts from the note, which gives us the documented performance. And so we now are in the process of doing some studies. These numbers on the right, just ignore those for now. That was from an earlier presentation. Um, but we have the ability to answer questions about how ambient versus ambient impacts anything that we're able to extract that looks like recorded versus documented performance. So very simple example of that. We noticed that in our papers that there seems to be much less time using the computer. And we were able to quickly quantify that because of the data that we actually have. You can see that for visits where you don't use DAX, the average computer use, which is down in the sort of lower right, is 28%. For visits where you do use DAX, the average computer use is 11%. So it's gone down pretty dramatically. And you can look at the rest of this. This is all a part of a larger publication that's coming out. We actually found an interesting feature that if you look at the bottom, you'll see that there are references to support it. We noted that laughing has changed and that provider laughing within the era of using DAX is going up. And you can see that on the videos, but we were actually able to quantify it. And we've noticed that laughter from the patient has basically gone, relatively speaking, down, but that's an artifact of time. Um, and what's very interesting about that is laughing is a measure of engagement. So this is a proxy for saying physician engagement is going up, but we're going to use some other methods as well to sort of understand how that actually looks in terms of provider dominance and some other aspects of it. Um, again, we have lots of data. What we don't have is a really beautifully balanced data set because once we started going from not DAX to DAX, there was kind of a tsunami of clinicians who were in the study where we never actually had a visit of them in the non-DAX world, but we have them in the DAX world. But you can begin to see a couple of trends here. Like if you look at exactly how the visit's being conducted with history taking and planning and rapport you can look at appears to be higher in the DAX group than in the non-DAX group. Maybe planning and counseling is lower, etc. Again, you can begin to see how recorded versus documented performance is going to be really helpful. In the interest of time, I'm just going to show one slide to show you some of the other work that we're able to do with this data set. We very quickly noticed that patients who had mild cognitive impairment may have features that we could detect. And if we could detect them just by getting them to answer some questions, we could create alerts like the alert on the right. This is one of the things I was hoping to be able to do with this project. So we should be able to listen, detect features, and have an explainable model about whether a patient is at increased risk for mild cognitive impairment. And just to quickly show, these are some of the features that we're looking at: speech display, filler speech, repetitive speech, word level errors, and vague speech. We have a series of models that we've used to try to identify how well this works. Actually, this slide's in the wrong place. We have a series of models that we've been using to try to figure out how each feature works. And we've used, some of them are sort of standard NLP strategies. Some of them are much more machine learning strategies. Um, these are some of the results that are being presented this year at PSB from one of my postdocs. And we found that we were able to get some pretty good performance from traditional NLP for filler speech and repetitive speech, but we needed audio and text to detect more complex indicators, as you can see on the slide here, which included things like substitution errors and vague speech, which has been the most vexing of all of the ones to choose. We're actually using the observer data, which is a very mildly affected group. And as you can see, when the observer data are brought in, the AUC goes down quite a bit and the F1 scores quite a bit lower. So now we're working on trying to do a better job of making sure that we can get rid of all of the false negatives in that data set. This is the project that I just showed you. This is some of the work that we're doing at a larger scale, including gait and movement assessment. And I'm going to show this picture of the lab and some of the postdocs and others who've been working on these projects, and then answer questions. And as you can see, our funding to the right.
Thank you.
Sure.
That was intimidating. So I'm gonna open the floor to questions, and we'll see who wants to jump up first. Or discussion. The whole point is to have the discussion. I'm gonna get it started while people get warmed up then.
Sure.
So I was curious about the laughter result.
Yeah.
I'm curious about a lot of the results, but the laughter result. So there's two things that I noticed, and I was curious if you could comment on them. So first of all, you saw the laughter component for the physicians jump up by almost double, but you saw it go down for the patients. And I was curious if you could comment on what the implication of that is.
So there's questions to ask about it first, right? So number one, sample. One of the big challenges with studies like this is we have far fewer providers than we would like to have, because providers for the observer study had to be consented just to be having broad consent for their data use. So I view this as a hypothesis generation exercise, which is to say, can we now do a more thorough study looking at how engagement has changed? But we have a signal suggesting that it has. The literature that's out there suggests that there's a researcher whose name is Deborah Roeder, who does work in patient-physician interaction. Laughter can be associated with provider dominance, meaning if the provider is laughing more, it may well be because the provider is talking more. It can also be associated with engagement, and that's the one that we believe is happening because we see that patient talk has not gone down. So that increase in time is likely increased provider talk. The questions we then have to ask ourselves are the ratio of provider open-ended questions to closed-ended questions. We'd expect that provider open-ended questions are going up. Therefore, there's more discussion. Therefore, there's more laughter. What's very clear when you look at observer data, and you'll all be able to look at it, is the closed-ended questions rule the day. Most people are talking to patients as if they're filling out a form. And interestingly, we do note one of the faculty here has done studies to show that there are some racial discrepancies between the extent to which there are closed-ended questions that generate assertional knowledge versus whether there are closed-ended questions that generate uncertain assertional knowledge. So patients saying things like, my legs are hurting so much I can't get to work. And the note saying, the patient reports some difficulty with ambulation, which is significantly less significant, important than what the patient actually said. And that we are able to detect some of that, and we're going to continue to look at it. But we think that what we're going to find here is a big shift in the way um, we know that there's more time spent communicating. The question is, what is it favoring? Is it favoring closed-ended or open-ended questions? And is laughter really representing engagement or dominance? Long answer to your question, Brad, but there's a lot to it.
No, I mean, it's a very simple question, but I know it's complex. Before I let Sarah jump in, I'm going to ask the question that Hannah put into the text, which was, do you foresee this work changing how patient rooms are designed? You mentioned the different room layout, how different room layouts might affect interactions.
Yeah, isn't that amazing? So I talked with the head of the general medicine division, and they're very aware of the fact that they use whatever space they have. So the answer to your question is, of course, we're going to get room design change, because the first question you have to ask yourself is, why is it that you would have a room where the patient literally can't see the doctor? And if that were the case, is there a mirror? Is there a monitor? Is there anything we can put in the room so that the view would actually be more favorable to interaction? Um, most of us ideally want the computer to be in a triangle equilateral from the patient and family and the provider so that we can actually share the screen, right? So that if there's something I want you to see about, this is what the knee looks like, we can go through it together. But a lot of these rooms really don't have anything like that. And when I show this to a lot of our general medicine people, they just nod and say, yeah, we hate our rooms. But I think we can use really, really, really simple ergonomic changes. And there's a group here called the Weitzman School of Design that is going to get involved with helping us to come up with technological approaches to making non-standard rooms functionally work the same.
Sorry, before Sarah jumps in, I want to push on this for a second because where you're going or where it seems you're going with this is that the notion of context influences care and that there's many different types of context. You can have physical context, you could have emotional context, you could have general relational context. And I'm kind of curious about how you view this. Like there's so many different things that you could document,
Yeah,
right? And you're doing it with video and you're doing it with audio. And then the question becomes, what are even the objects or concepts that matter
yeah.
or could be used as features in any type of an investigation? Like
Well,
sounds like it's
yeah.
a
So
preview
this
world of
is
effects.
Yeah, and I think you couldn't have said it more eloquently. The goal of this project, from my perspective, is to externalize the view so that we can bridge disciplines going into medicine. So we've done a few experiments here to demonstrate the potential of that particular technology. And because of my interest in documentation, we'll continue to do work thinking about what are we learning from these new documentation strategies. But I'm not a room designer. The good news is we have a Weitzman School of Design and other people in engineering who think about this. And now I'm giving them data that they can actually, as a group, look at it and say, let's do some experiments to figure out whether this design is better than this other design. So I view this not unlike the way we started out with BioView or All of Us, which is to say this is a hypothesis generating platform with a goal of having fair data so that every one of you can have access to the same data and design your same experiments, much like Bridge2AI Voice is doing, and much like other groups are doing around the country. But no one's doing it with video because they're terrified of video. And so my goal is to try to make it possible to bring together the video that we have in hundreds of repositories of basically video that's hiding in people's desks because they don't have broad consent to share it, so that we can do these kinds of projects.
Cool. All right, Sarah.
Thank you. And you may have gotten at my question. I actually had two questions. The second one's super brief, but the one I was thinking about was this is like really interesting technology, and I can imagine it doing all sorts of things. Presumably, the goal here is to improve the care that gets delivered in these settings. And I'm curious to know what mechanisms through which you think there is the greatest promise for accomplishing that? Is it giving feedback to clinicians so that they can improve what they're doing? Is it offloading the responsibility for documentation so they have more time to build relationships? I wonder where you think there is most promise. And then the second question I had comes from, I'm actually working with similar technologies in surgical settings, OR black box, where we do all, and I'm just wondering if you're talking with them a lot, or at least looking at the applications that they're using in order to think about how to do it in the primary care setting. I just didn't know you were working on this. I just think the parallels are fascinating.
They are. So first of all, really excellent question set, and I appreciate both of them. I think the answer to the first one is it's going to be a multifactorial strategy. The point that Brad was just bringing up, which is, are you going to fix the rooms, right? People don't typically call the informatician in to fix the rooms, and engineers want nothing less than to fix a room. But our campus is loaded with people. So part of the answer to this is exposure, right? Part of the answer to, you know, even though we've politically been forced to make every paper open access, I've been pretty much putting everything that we've been generating in the open access space because my hope is that sociology, social work, nursing, others will find this repository and will resonate with some question that they've been curious about, that they now have data to support that curiosity, either to answer the question through observational research or to design a much more elegant hypothesis testing strategy to answer that question. So that's already happening on the campus. We just submitted, we just released a pilot request. We were giving $20,000 grants, really small, but full access to all the data. We had, I think it was 30 some 32 pilot letters of intent. We're awarding 5 grants. So right now I have a stack right here. This is everything I'm supposed to read, which is all the proposals that are in the 5. The final proposals are all in. So we're going to award, I guess that's 9 of them. So we're going to award 5 of those access and funding to do something completely different. And some of them are just, I want to use the EHR audit log to better understand what is happening when doctors who are using ambient scribing are still using the EHR, because maybe we can get that out of the EHR so that they don't even have to use it, i.e., maybe they can use something more like an Alexa-like device to ask those questions, or what I call an EHR adjacent technology. So the first answer is yes, we're hoping that this is democratizing the ability to answer the questions, not in any way consolidating it in my little lab. Your second question, now, which I tried to not forget, but I've forgotten it.
It was about surgery versus
Oh,
primary
yeah.
care opportunities.
Thank you. Dan Hashimoto, who I think you may know. Do you know Dan?
I do not. I've been
Okay,
working with the
Dan.
Stanford group, Theodore Grantроff and Safe Surgical Technologies.
Yes, and actually, did you work with Feifei on any of her work?
A little bit, yeah.
Yeah. So we've been in touch with all of them, but Dan Hashimoto is a local colleague and friend here who's done a lot of work looking at AI-assisted minimally invasive surgery, but also med ed. And he also has been collecting similar data to help understand how endoscopic and other procedures can be automated with real-time alerts about where one should, cut and where one should not.
Hmm.
The work I've mostly seen is his work around cholecystectomies, but he's also been looking at our OR black box work, which was created in a group we have called Penn Connected Care.
Hmm.
And Dan has been trying to get his grant funded to do the exact same work I'm doing, and it's going to be a part of the same repository. So his data will also be in the Observer repository for surgeons. And if there's others, Sarah, that you think we should be connecting with, we just submitted an R24 to try to turn this into a larger colloquium so that we could bring all of our data into one place and make it easily accessible to others. So thank you. Happy to chat about that more.
Yeah, great.
Mhm. Andrew.
Hi all. So I had a question and a quick share before that when we had that big AI contest with UCSD Health where we all put in our proposals, The one I did was a lot of people were doing scribes, but I was doing something different, and I want to just share and get your kind of feedback on how we can make this work.
Sure.
I submitted ERIS, the Emergency Response Information System, which really meant for our first responders, our paramedics out in the field and such, so that just along lines of what you were just saying, they could get on the spot information gathered, curated by AI, what's
Yeah.
relevant to the current case. And of course, these are not MDs usually, but they're medical professionals. And so them to get data curated to the current case, current drugs the person was on, that sort of information if the person's not able to communicate well, and other key information on the scene, while at the same time they're feeding information back in to get to the doctors that are waiting there at the emergency room. And but what do you think? How are we going to deal with all this HIPAA stuff in terms of, I wanted to reach into Epic and reach into the San Diego Behavioral Health and all those systems. And of course, that sounded too bold at the time.
Well, so first of all, Andrew, in case you haven't already seen it, there's a video on YouTube by John Sculley, former CEO of Apple, called Healthcare 2008. If you look up Healthcare 2008, you're going to see your vision completely enacted by paramedics, a cardiologist, an ICU, and a patient who's on a bike. And I think that if you look at that, you're gonna say, exactly, that's what I want to do. So HIPAA only becomes important if you turn this into something that looks at real patients that is not a quality improvement project. So any other way that you do this, you can actually go through the project and be completely in line with the rules of being in a covered entity, meaning that patients can give consent, you can do the work you want to do, you make sure that the data aren't being disclosed in any other way. And I'm always remiss when there's somebody like Malin on the call that I should probably say to him, am I right? So I'm going to end it by saying, Brad, am I right?
You're right, but I was saying, so this actually sounds very similar to work that I'm aware of that Daniel Fabry and others were working on that were sponsored by the Defense Department, because they were trying to figure out how, if you had first responders and they were in transit
Right,
into a trauma ward or into the ED, how do you take, they had wearables on their hands so they could see what they were doing, as well as
right,
they were detecting the signals off of them. And then the question was, how do you summarize that? The
right.
summarization component was not solved to the best of my knowledge. There was a
Totally solved
lot
now.
of say what?
It's totally solved now.
Well,
VLMs can do this beautifully.
but I think that this is an idea that people have been thinking about for quite
Right.
some time. And I think it's
Yep.
this is one of those things that's like you're trying to minimize the amount of time in a environment where people are crunched for time. So
Right.
it's a great idea, and optimization opportunities are never going to go away.
Right. But Andrew, I guess the rest of the answer to your question is, I wouldn't worry so much about the HIPAA issues. I would design good experiments and then make some decisions about um, who actually has to see what. How much of this can be done with standardized patients? How much of this can be done using either an existing tools? I wouldn't even so much worry about Epic at this very instant, because there are other ways to get access to some of this data. And if all you're trying to do from a research perspective is to demonstrate how summarization and sort of real-time access to questions that are being asked on the scene can be accomplished, I think you can pull that off in ways that don't trip too many wires of people's concern.
So if there's nobody stepping up to the mic, I want to push on things a little bit.
Sure.
So
And I see Doug Bell on here, so I know he's got a question, by the way.
I just got called out.
No,
That's what I do.
thank you,
What I
but
do.
I don't. It's very impressive what you're doing. It's really way ahead of where most people are. So you know, um,
Well, thanks.
it's really okay. A question. So how much are you using LLMs to analyze the data, right? Especially transcript data. Um,
How
Is
much
that
are
it?
we? A lot.
Yeah, a
Um,
lot.
ev-
Yeah.
yeah, everything that we're doing with regard to the recorded and documented performance part is using LLMs because it's a very efficient way. You know, we have ontologies for a lot of things, but one of the earliest experiments we did that I frankly didn't put in the literature because I think people know it is that the ability to map cleanly from patient speak to our existing terminologies is pretty bad. And so we need an actual ontology on the transcript side of the world that maps it back into the medical side of the world. And we all know a few terms, but we don't know a lot of terms. So it turns out that you can do that work very efficiently with large language models because you can use RAG iteratively to come up with a term set and to let it then tell you whether one of the terms you've already identified or another term is represented in each sentence or no term at all. And so we did that during the first summer to come up with a general sense. Spoiler alert, the slides I didn't show you, one of my students is doing a project that I'm super excited about, which is automated clinical agenda management, where we are basically trying to determine whether we can create a real-time topic model during the visit and actually include both verbal and nonverbal topics, and then resolve those topics during the visit. So we can see what's being discussed and make a decision that we've adequately covered whatever we define as a resolved agenda item. So his work has basically been trying to extend topic modeling to include this notion of an agenda item, which are different than topics because agenda items get covered. They don't just get discussed, and there should be some movement toward resolution, which is the kind of stuff LLMs do very, very well if you can find the agenda item. So we think that LLMs are really opening the door to understanding natural language in these kind of real-time ways. Um, and frankly, just to give you a little bit of technical geekiness, the biggest challenge here has to do with the context window. So if you're trying to do it in real time, sentences aren't good enough because that's almost like a little bit of a Markov process. You keep losing track of state and you don't actually know that this particular sentence relates back to a state that was identified a long time ago. So what we're trying to do is to find an ideal context window where we can confidently say, this is a topic, and then confidently say, this is a resolution. And that work showed up in AAAI last year. So that's out there for people who are interested. If you look up Samir Bhatti, or I can send it to anybody who's interested. I think it's also, everything we've done is pretty much in medRxiv, if it wasn't already accepted someplace else. So I'm sure that's in medRxiv. So Doug, that was a long answer, but LLMs are a big deal here.
So
Great.
what are you doing with the data in terms of like, so how for each interaction or for each episode, how much data is being generated? Just how is it being managed? Where is it going at the end of the day? And how easy is it to process? Because I can imagine like this is you showed your pipeline, and as you know, yes, the data geek in me goes, that's a non-trivial amount of engineering, and there's an amazing amount of lift associated with this. And so if somebody was going to try and do their own analysis, like how challenging would it be?
So here's what you guys need to see. If you can remember Observer Dashboard on Google, you'll get to this. Or if you put in my name Observer, observer.med.upenn, any of these, this is it. So that's the answer to your question. So everything about it's here. You can see the data set a couple of different ways.
And it's all being hosted at Penn?
It's all being hosted at Penn right now. This is the dashboard I just showed you. So these are our current numbers as of August 7th. It'll be updated again soon. 233 encounters. We have 221 de-identified. 111 are completely access controlled, meaning patients have prevented us from being able to share them without a little bit of additional work. There are 4 departments that are represented. You can see those here. You can do all the searching that you want to do here. We're actually adding a metadata filter and a word cloud. We're working on that right now. If you want to see any one data set, I happen to have one that we got consent to show early. So this is all of the data. This is the name of this is the information about the provider. This is information about the patient. These are the clinical visits that have been recorded. We actually have the clinical notes here for this patient. We get approval for notes from 24 hours before until 72 hours after the visit so that we can capture messages and ordering. We have all their conditions and diagnoses right here. Medications are right here. Procedures are right here. You see what I'm doing with this. So everything's here. We have multimodal data. So in this particular visit, we have a patient view video, a provider view video, a room view GoPro camera, and a transcript. You can click on the transcript. Maybe not here. I probably have to go further and I have to go someplace else to get to the transcript. It's in here for sure. But there's everything. We have it OMOP concepted. So anything that you want to merge, if you wanted to look at it relative to OMOP data, you could. All the audit log data are right here. So that's what we're
So
doing.
is it gigabytes, terabytes?
It is currently about 100 gigabytes.
Okay, reasonable.
We actually shot at 60 frames per second, and obviously that's a lot. So we're
Yeah.
dropping it down to 30 frames per second. We actually are doing an analysis right now to look at attention, how much time is being spent actually using the computer and to do it with an automated method. And we're taking that version of it down to 2 frames per second. As I mentioned from the first slide, we redeposit all derived versions. So there will then be 2 frame per second video in here as well. And that's going to be a requirement of anybody who does a study. To the extent that you actually modify the data set, we want it redeposited.
Yeah.
And Brad, you're going to be seeing this really up close and personal,
Well,
really, really soon.
but there's other people here.
I know.
So
I know.
so play
I'm
this
just
through.
making it easy.
So Bridge is dealing with its own challenges around controlled access data repositories and making data accessible in a manner that is supposed to support the NIH's philosophy of broad data sharing.
Right.
So what does data access in a controlled repository look like for you guys? So is it
Yeah.
a request to Kevin Johnson? Is it something that has to go to Penn's IRB? Is it a partnership model? Is there a data use agreement? What does that process look like?
So one of the reasons why all of the pilot projects are internal was that we have to address those questions. We have an internal advisory board, and they have many people. They have people from our Office of Counsel, OCR or OGC rather. We have I forgot which letters those were. We have
And
an IRB officer.
depends on
We
if you want civil rights or if you want legal counsel. Pick.
Exactly. I kind of need them both, especially these days. Um, and so we have a group of people whose job is to help us think this through. And the first thing they said is, please let's not share this yet. Uh,
Mm,
and so we are sharing it. The one data set that you see there is one person who's been allowed to share everything. But for the most part, we haven't gone back. And even though we have broad consent from almost every single person there, um, there are stipulations to all of that, mostly having to do with making sure that we've appropriately obfuscated everything that they considered personally identifiable. Yes, um, I can post the link in the chat. Although honestly, if you Google observer, you're going to find it. If you put in Penn Observer Dashboard, you don't need me. But observer.med.penn.upenn.edu. That's the link. Come in. Oh, yeah, here it is. There. There. I'm glad I got it right. Well, mine didn't go in yet. There. Oh,
I
there's
beat you to it.
Yeah, you did. You're good. Okay. Doug, did that answer your question? I already answered your question. What was the other question I was asking? It was yours, Brad, right? What else do you have for me?
I mean, it's just the general process around this. So what you're
Yeah,
doing is you're doing something that's extremely different than what's been done in the past. I think even with the surgical setting, it's very different. In a surgical setting, you have a situation in which, for the most part, unless Sarah wants to tell me otherwise, this is not about patient interaction. This is not about dynamic set of interactions between a care provider and an individual who is trying to interpret what they're saying, potentially even being a little adversarial with respect to their interactions with the clinician. And
right.
in this situation, you're talking about a situation where you've got dialogue
Right.
in a way in which you have different languages, you would potentially have different vernacular, and so trying to resolve just what does this make? What is this
Yeah.
entirely? It's like, you're just like you're like almost I'm gonna invoke the words of Will Bush, you're like a data knot, and that like you're like on this escapade that's like completely novel and like
Yeah.
what does that look like to like chart the world by yourself?
Can I
Well,
can I just say, Sir Kevin, just on behalf of surgery, that was part of why I asked the question that I asked Kevin, which is sort of what are the mechanisms that he's most excited about the potential for this? Because in surgery, I got involved in working on this in surgery because of the opportunities to impact team dynamics, because
mhm.
the conversations that we can observe are happening between the people in the operating room. But you're exactly right, and I'll turn back over to Kevin. Like
Yeah,
what's
no.
exciting about the primary care setting is the opportunity to impact the conversations that go on between the doctor and the patient, or the practitioner and the patient, or clinician and the patient, which is really different.
So this project was funded by a Pioneer Award, which is a high risk, reward grant. And as you can tell, it's high risk and high reward. Um, we spent the first year in the Penn Simulation Center looking at a lot of different equipment. If you look really closely at that video, that picture I had that had the arrows, if you look on the desk, you'll see that there were 5 different camera types. We tried lavalier mics, we tried a bunch of different technology. And once we thought we got it right, we created a physician advisory board, a nursing advisory group, rather, and a patient advisory group. And we talked about the entire process. Some of this will show up in the Observer paper that's in JAMIA. One of the things that we learned pretty quickly from the patients was, you know, nothing about me without me. So we absolutely want to do our own survey about this visit. We don't just want you to survey the provider. We absolutely want to carry a camera so that you can see what we see too. We thought that was going to slow things down, but we've been able to use a fairly lightweight egocentric camera that fits over the head. We tested that numerous times. We have a research assistant team who, after we've gotten consent from the provider, and then after we consent the provider, we consent patients, shows up at the visit, turns on all the equipment, and we monitor from the outside so that we can be minimally obtrusive. But we always ask in the survey, to what extent did the technology impact what was happening during the visit today? Um, I believe that method, which we've created, can easily be used by any other specialty who wants to do similar types of work. But I'm not smart enough to be able to figure out the nuances. Some of you now know that I'm a pediatrician, and you're going to wonder, why am I not doing this in pediatrics? And the answer to that's quite simple. Pediatrics is more than minimal risk. So for me to do this well, I had to nail doing it in the adults so that I could get IR approval, which we now have, to start collecting these data in primary care at the Children's Hospital. So I'm now working with a guy, Bob Grunmeyer, and we're going to set up an observer, exactly the same as what we've done here, same exact method, same exact guidebook, to collect the data in pediatrics. Pediatrics has a lot of things that make it more challenging. For one, you talk to a parent, not the patient, but the patient has a voice that's typically screaming or occasionally talking. There are often more than one caregiver, therefore it's going to be much more challenging to do role identification, but we can try. But we also think that the more providers we involve, the better we get at making a useful data resource for bridging the campus and the world.
So can we have 3 minutes-ish left, and I wanted to turn to one of the questions that showed up in the chat because I think it's probably on the minds of a lot of people that will watch this video, which is the question around, the does the recording of the observation or the interaction, is that going to potentially impact the interaction itself as opposed to just being a passive observer?
Yeah.
And so do you have any concerns, or do you get excited about the integration of this technology in that manner?
So common sense, of course, it probably has impacts the interaction. We are actually asking that question of both the patient and the clinician at the end of every single recorded encounter. All of those data are in the observer repository, and it's 2 different surveys to try to get both a sense of the quality of the visit, as well as some very specific ones about computer familiarity and comfort with this technology. The probably most reassuring thing is that we often have to go in the room and remind people to take off the cameras because they forget they're in there. So that's very, very common, that people will walk out and my research coordinators will say, wait a second, we've got to take the camera off your head. Oh my God, it's still on. They just don't even think about it. And that happened to me. I was a subject in this. And so when I did it, same thing as everybody else. I happened to know we were doing it, but I remembered, yeah, I got the camera on. We were talking about something and I realized, oh yeah, my doctor's camera is still running. So we think it has an impact, but the question is it such an impact that it affects the quality of the data? And the people who were asked that question, who were given a survey, say it doesn't. There are probably, I'm forgetting what we just reported. It's a small number of providers who said that there were negative impacts. Um, a few providers actually said there were positive impacts because it made them have more of a conversation about some of what they were observing. And
Yeah.
so we'll see how all this plays out. But the other question that many people might be asking me is, well, if you're consenting providers, how do you know these data aren't biased? And the answer is this is a total convenience sample. It is completely biased in every way you can bias it. We do allow patients with other languages to participate, but many of the providers are actually very uncomfortable because I think they also suspect that their care is different when there are patients with different languages. So as we do this for longer, I expect that we're going to have an even richer data set and be able to get at some of those particular issues. We also have providers who are more comfortable and are letting us pretty much see any patient of theirs that they want. For the first year, because people were concerned that we were going to impact clinic flow, providers typically said, and I know I'm using providers, I should be using clinicians, I apologize, but clinicians typically said, let's just do the first visit in the morning and the afternoon. Don't come in the middle because if I'm running behind, this isn't going to help. And if patients show up late, this is going to be a mess. So first visits are the only ones. We're now doing any visit we want. So
So
once the provider
we got -5 seconds, and in the -5 seconds, last question. What do you anticipate is the approximate timeline for when outside researchers might be able to request access?
6 months.
All right, there you go. You heard it. All right,
So
everybody.
Brad, can you come visit me in about 2 months?
I don't know, Philadelphia in the wintertime. I grew up there. There's a reason why I left. So thank you very much, Kevin. If you have follow-up questions, send them his way, send them our way, and we'll pass them along. But otherwise, thank you very much. This was fantastic. Really appreciate
Sure.
it.
My email address is hard to find, hard to not find. It's everywhere, but it's basically if you put in Jokevin, Jokevin at upenn.edu, that'll work. It really is Joe Kevin, but Jokevin
That's
is,
fine.
yeah.
All right. Thanks, everybody.
All right, thank you. Great seeing you.